Morning students, this is Usha from G.K.Jain High Secondary School. Today we are going to learn about an understanding of errors and correction in physical quantities. Let us move on to the topic. Theory of errors. The foundation of all experimental science and technology is measurement. But all the measurement value contains some uncertainty called errors. The important two terms are accuracy. It refers how far we are from the true value. Next one is precision. It refers to how well we measure. Here an visual example is given. A target shooting is an example which explains the difference between your accuracy and precision. In the first diagram, we can see that the shots are focused so as to reach the bull's eye, but the arrow have reached only around the point. So hence the shots are not accurate and also they are not precise. The second one diagram shows all the shots are close to each other but not at the central point. Hence the shots are said to be precise but not accurate. And the third one shows the shots are close and also at the central point. Hence the shots are both precise and accurate. Next we'll go into the types of errors. Right? So the uncertainty in a measurement it's called an error. So there are random error, systematic error and gross error are the three possible errors. First we'll see about the systematic error. Systematic errors are reproducible inaccuracies that are consistently in the same direction. They are difficult to detect and cannot be analyzed statistically. Systematic errors can be classified as follows. The first one is instrumental errors. Right? When an instrument is not calibrated properly at the time of manufacture, instrumental errors may arise. So the errors can be corrected by choosing the instrument carefully. The second one is imperfection in experimental technique or procedure. This arises due to the limitation in the experimental arrangement. This error can overcome by during corrections, right, and has to be applied. Personal errors. These errors are due to individual performing the experiment, may be due to the incorrect initial setup or carelessness of the individual making the observation due to improper precaution. Errors due to external causes. The change in the external conditions during an experiment can cause errors in measurement. And last one is least count error. It is the smallest value that can be measured by the measuring instrument, and the error due to this measurement is least count error. So least count error can be reduced by using a high precision instrument for the measurement. Next one is random errors. Random errors may arise due to random and unpredictable variation in experimental conditions like pressure, temperature, voltage, supply, etc. So error may also due to personal errors by the observer who performed the experiment. This error sometimes called as change error. They can be evaluated to statistical analysis and can be reduced by averaging over a large number of observations. Next one is gross error. The error caused due to the sheer carelessness of an observer is called gross error. It can be minimized only when an observer is careful and mentally alert. Next, we will move into the error analysis. The first one is absolute error. The magnitude between the true value and the measured value of an quantity is called absolute error. If an experiment performed n times, then the arithmetic mean of the measured value is called the true value AM. We can do it by mathematical process. AM is equal to A1 plus A2 etc. up to AN divided by N, which is equal to 1 by N times summation I is equal to 1 to N into AI. Hence, the absolute error in measurement value is given by modulus of delta A1 is equal to modulus of AM minus A1. The same way we can do for up to AN terms. Delta AN is equal to, that is modulus of delta AN is equal to modulus of AM minus AN. Mean absolute value. The arithmetic mean of the magnitude of absolute value in all the measurement, it's called the mean absolute error. So delta AM is equal to delta A1 plus delta A2 etc. up to delta AN. divided by n. So which is equal to 1 by n times summation I is equal to 1 to n delta of ai. Then the magnitude of the quantity may lie between am plus delta am and am minus delta am. Next is relative error, or it is also called as fractional error. It is a ratio of mean absolute error to the mean value. So relative error is equal to delta am divided by am. Percentage error. The relative error expressed as a percentage is called percentage error. Percentage error is equal to delta am divided by am into 100%. A percentage error very close to 0 means 1 is close to the targeted value, which is good and acceptable. Propagation of errors. A number of measurement quantities may be involved in the final calculation of an experiment. The first one is the error in the sum of two quantities. So measurement value of A is equal to A plus or minus delta A, and the measured value of B is B plus or minus delta B. And consider the sum Z is equal to A plus B, right, where delta A and delta B be the absolute error in the two quantities A and B respectively. Then the error delta Z in Z is Z plus or minus delta Z is equal to A plus or minus delta A plus B plus or minus delta B. Now we'll bring A plus B together and delta A plus delta B as the second term. So we'll get it as Z plus or minus delta Z is equal to A plus B plus or minus delta A plus delta B. Now as we have measured values, that is Z is equal to A plus B, we will substitute there. So we will get Z plus or minus delta Z is equal to Z plus or minus delta A plus delta B. Now Z, when I bring it to the other side, it become negative, so Z get cancelled. So we will get it as delta Z is equal to delta A plus delta B, which shows that the maximum possible error in the sum of two quantities is equal to the sum of the absolute error in the individual quantities. Next is error in the difference of two quantities. So let delta A and delta B be the absolute values in the two quantities A and B. Then measured value of A plus or minus delta A, and measured value of B equal to B plus or minus delta B. Let the difference be Z is equal to A minus B. Then the error delta Z in Z is Z plus or minus delta Z equal to A minus B plus or minus delta A plus delta B. As we all know that Z is equal to A minus B, substituting we get Z plus or minus delta Z is equal to Z plus or minus delta A plus delta B. Cancelling Z on both the sides, we will get delta Z is equal to delta A plus delta B. The maximum error in difference of two quantities is equal to the sum of the absolute errors in the individual quantities. Errors in the product of two quantities. Let delta A and delta B be the absolute errors in the two quantities A and B. Then the product Z is equal to AB. So as usual, we'll take measured value of A is equal to A plus or minus AB. That is A plus or minus delta A, and measured value of B is equal to B plus or minus delta B. Then the error delta Z in Z is Z plus or minus delta Z is equal to AB plus or minus A into delta B plus or minus B into delta A plus or minus delta A delta B. Now divide throughout by Z. So we'll get 1 plus or minus delta Z by Z on my left hand side, and on my right hand side, so AB is Z. So Z by Z, once again we'll get it as 1. So 1 plus or minus delta B divided by B, because A will get cancelled, and then plus or minus delta A divided by A, in the third term B will get cancelled. So plus or minus, we'll make this delta A divided by A and delta B divided by B. Individually we'll make it. Then we'll get 1 will get cancelled on both the sides. So we'll get delta Z by Z is equal to plus or minus delta A by A plus delta B by B. From this we can say that the maximum fractional error in the product of two quantities is equal to the sum of the fractional error in the individual quantities. Errors in the division of two quantities. Let delta A and delta B be the absolute error in the two quantities A and B. Consider the quotient z is equal to a by b. Then the error in delta z in z is z plus or minus delta z is equal to a plus or minus delta a divided by b plus or minus delta b. So now you take a outside, so you'll get 1 plus or minus delta a by a. In the denominator b, when we take it out, 1 plus or minus delta b by b. And rearranging, we'll get the terms as 1 plus or minus delta z is equal to 1 plus or minus delta b by b plus or minus delta a by a plus or minus delta a by a into delta b by b. So subtract, that is cancelling 1 on both the sides, we'll get delta z by z is equal to plus or minus delta a by a plus delta b by b. So which shows that the maximum fractional error in the quotient of two quantities is equal to the sum of their individual fractional errors. Next is errors in the power of a quantity. So consider the nth power of a, that is z is equal to a power n. Then the error delta z in z is given by z plus or minus delta z is equal to a plus or minus delta a the whole thing power n. So which is equal to a power n into 1 plus or minus delta a divided by a whole power n. So 1 plus or minus delta z by z is equal to, as you know, a by n is equal to z. Substituting, we'll get z into 1 plus or minus n into delta a divided by a. By using 1 plus x the whole power, n is equal to 1 plus nx, neglecting all the other terms. Dividing both sides by z, so we'll get 1 plus or minus delta z by z is equal to 1 plus or minus n into delta a divided by a. So we'll get delta z by z is equal to n into delta a divided by a. This shows that the fractional error in the nth power of the quantity is n times the fractional error in that quantity. Next one is your general rule. So the general rule, we'll write it as if they are giving a value z is equal to a power b, b power q divided by c power r, then the maximum fractional error in z is given by delta z by z is equal to p into the power which is there, that first you have to write p into delta a divided by a plus q into delta b divided by b plus r into delta c divided by z. So the percentage error in z is given by, so if they ask for percentage, you have to multiply with 100. So we'll get it as delta z by z into 100 is equal to p into delta a divided by a into 100 plus q into delta b divided by b into 100 plus r into delta c divided by c into 100. This is the general rule. Yes, students, you all have learned about the different errors and the corrections in physical quantities. Let me meet you in the next video. Thank you, students.